Or go to math.com, click on calculus, and let's go down to related rates. I believe we're in this section right here. Let's click on 9-1 and work this problem for the third time. First time I think I made some kind of little arithmetic error, got to the end, it wasn't the right answer. Take two, take three. And then this next time around, I get all the way to the end, I close the problem out, bring up the home page, and it turned out at some point in time, 2 minutes into the video, I paused it and I didn't notice it. So I just kept on talking and working the problem out till I get to the very end. I close the page out, go back to the home page. I look down to transfer the video, and it shows like 2 minutes and 2 seconds on there. So at some point in time, I paused it and forgot I did that. So here we are working this problem a third time around. So I don't know about you, but I'm getting this stuff down. Okay, so I wrote down, oh my gosh, find the rate of change of the distance between the origin and a moving point on the graph of. All right, let's bring up something here. Let me sketch. Let's just sketch out. I should probably write our information down first and then do the sketching. And so that's probably what I should do. We got y is equal to, I hope I don't have to do this video again, 3x plus 5. Of course, I did all this video for this section 2 weeks ago, but then I woke up in the middle of the night going, you know what? I'm going to redo the website and write it from scratch. I think I can do it better. And so then I spent 3 days doing that, or 4. I mean, it is a whole lot better. I was inspired by the New York Times website somehow. I don't know how, but I was. I mean, it's not anything like it, but anyway, something about the New York Times website. Where are we at? Okay, so this is what we're given. Now, let me sketch this line out over here. And if you notice, their website's all about black and white. It's all black and white. So there you go. 4 centimeters. We'll label 4 on the x-axis right here. So we got a point on the curve, and then we got the origin right here. And they're asking about what's the rate of change of this distance from the point to the origin. Now we got a moving point. In other words, this point is moving along this graph right here. And then at this exact instant, when x is 4 centimeters and dx over dt is 1 centimeter per second, okay, we're wanting to know the distance. We're wanting to know this, d over dt, and this represents the rate of change of the distance with respect to time. And that distance would be between the origin and this point right here. So if we're talking about the distance, then we probably need to start with the distance formula. The distance formula, do we all remember that? It's d squared is equal to x of 2 minus x of 1 squared plus y2 minus y1 squared. Okay? So in other words, we need to take the derivative of this thing with respect to t and then solve for dd over dt here. That's what we need to do. And let's look at some things first off. Where are we going to get these x of 2's, x of 1's, y of 2's, and y of 1's? Well, we're going to let the origin be one of our ordered pairs, and that'll be 0, 0, and that's going to actually be x of 1, y of 1. And then this one will be 4, obviously, is our x value, and then our y value, we'll get that from here. So we'll want to take 4 and plug it in up here. So 4 times 3 is 12, and 12 plus 5 is 17. Is that right? 4 plus 3 is 12. 5, 6, yeah, that's right, 17. Okay, so there's our, this will be our x of 2 and our y of 2. Okay, so we got those guys. Now we'll need to get some other stuff here, but first off, let's go ahead and take the derivative of this. So we're going to take the derivative, take the 2 out front, and then we write dd over dt. Alright, then we take the derivative of this, take the 2 out front, then we're going to write x of 2 minus x of 1 times dx over dt, and then do the same thing here, 2 y2 minus y1, and then this will be dy over dt. Now let's look at this. We have a 2 in each one of these terms, so we can multiply through by half all the way through and get rid of these 2's. Alright, and also we're going to go ahead and plug our numbers in for x of 2. We're going to plug these ordered pairs in, collapse that down. So we end up with d times d over dt. So we have x of 2, which is right here, 4, minus, and then our x of 1 is 0 from the origin, and then dx over dt, what is that? Where's that at? That's right here, right? 1, shows it to be 1. And then we have plus, let's see, y of 2, so this is our y, 17, minus, and then here's our y1, 0. Now, what about our dy over dt? What is that? Well, that's going to come from here, and that means we're going to take the derivative of this guy right here. So let's do some side work here, and I'm going to take that off the screen, but I'll just end up rewriting it here. So we have y is equal to 3x plus 5. Now we want to take the derivative of this. So we have dy over dt is equal to 3 times dx over dt. And now what we can do is go ahead and plug in. So dy over dt is equal to 3 times, and dx over dt was 1 centimeter per second, so 1. So it turns out that dy over dt is 3. Would be 3 centimeters per second. But we're going to plug that in for this right here, right? Dy over dt, so that would be 3 goes there. Alright. Now let's just go ahead and simplify all this down. So we end up with d times dd over dt is equal to, so 4 minus 0 is 4, and 4 times 1 is 4. We'll go ahead and write that there, plus, and then we have 17 minus 0 is 17, and 17 times 3 is 51, right? 51, I hope. Alright, now we got this d right here. Now this d is going to end up representing the distance from the origin to this point right here. Okay, so to solve for that, we have dd over dt is equal to, so this is going to end up being 55. Hope I hadn't made any mistakes on that. Over, and of course this is going to be d, and d is equal to, remember, the square root of the change in x's squared plus the change in y's. But since we've got 0, 0, we're just going to be looking at these numbers here. So this is going to be 4 squared plus 17 squared. And then I'm going to go ahead and plug that into something. We have approximately, that's what these squiggly lines mean, and then let's see what this is approximately equal to. Holding our breath. So we got 16 plus 4 squared 16, right? And 17 squared. Wow, that's almost like pi. Close, ending with 3.14. That's interesting. All right, I end up getting 3.1. It is 1.4, but we got to round up. 3.15 is what I end up with. Oh man, I almost clicked that button right there. I have done that before, and it is not good. Okay, finally, this video's been complete. dd over dt is 3.15 centimeters per second. Now, you want to make sure you don't leave off your units. If you're given units in a problem, don't ever leave them off, or I promise you that teacher Hatchet there will definitely count it wrong. Okay, so there you go. And you know where we are. We're at gotomath.com, and I'll see you